All right, let's jump right in. Have you ever felt like the world is running on some kind of secret code? Like there's a password you just don't have? Well, guess what? You're not wrong. There is a code. And today, we're not just going to find the password, we are going to crack the entire system. Okay, let's be honest. How many of you have sat in a math or physics class staring at a bunch of equations and weird letters and thought to yourself, when am I ever going to use this in my actual life? It's a totally fair question, I get it. Sometimes this stuff can feel like it's from another planet. But here's the wild part. The answer is you use it. Literally, every single day. See, physics isn't just a class you have to pass. It's the invisible operating system running in the background of your life. It's in the bounce of a basketball, the music coming through your headphones, everything. And I'm going to show you how. Now, to crack this code, you don't need some genius-level IQ or a supercomputer. All you need is one simple key concept. Seriously, this one idea is the master key that unlocks almost everything we're going to talk about. And that idea is variation. Sounds simple, right? That's because it is. So, this whole variation thing basically comes in two flavors. First up, you've got direct variation. That's just when two things change in the same direction. The more you study, the higher your test score goes. More of this, more of that. Then there's inverse variation. This is when they go in opposite directions. The more time you spend on video games, the less time you have for homework. More of this, less of that. Got it? Awesome. Let's start using this key. All right, player one, ready? Welcome to level 1 of the secret code. This level is all about the physics behind anything that can stretch, squish, or bounce back into shape. It's called Hooke's Law, and believe it or not, you've been an expert on it your whole life. And this dude right here, this is Robert Hooke. He's the guy who literally wrote this piece of the code way back in the 17th century. He was totally obsessed with springs and stretchy stuff. So next time you jump on a trampoline, you can thank him. So what was this big idea? Hooke's law just says that how far a spring stretches is directly proportional to the force you use to pull it. Wait a second. Directly proportional? That's our old friend direct variation. All it means is the harder you pull, the longer it gets. That's it. Okay, now don't freak out, but here's what the code looks like in math. F equals negative k times x. I know, letters in math can be annoying, but it's simple, I promise. F is just the force, your pull. X is how far it stretches. And K? K is just a number that tells you how stiff the spring is. A big K means you've got a really tough spring. Okay, agent, time for your first mission. We've got a spring, and we know its stiffness, its K, is 0.4. We're going to apply a force, F, of 4 newtons. Your mission, should you choose to accept it, is to figure out how far is this thing going to stretch. Let's plug it into the code. We just pop in the numbers, do a little bit of quick math, and bam, x equals 10 meters. And that little negative sign, don't even worry about it. It's just physics' way of saying the force is stretching it outwards. You just used a 300-year-old code to predict something. How cool is that? Level 1 complete. You crushed level 1. So, ready for level 2? We're leveling up from things that stretch to, well, everything that moves. We're talking about the secret code that runs everything from a football flying through the air to planets flying through space. Welcome to the world of Isaac Newton. Now here's a little hot goss from the 1600s. Remember our guy Robert Hooke from level 1? Well, he and Newton were huge rivals. Like, they could not stand each other. Hooke actually sued Newton, saying he stole all his ideas about gravity. A little 17th century physics drama for ya. So what was Newton's game-changing idea? Well, his second law is like a 2-for-1 special on variation. First, an object's acceleration is directly proportional to force. More push, more speed. Simple. But it's also inversely proportional to mass. More weight, less speed. Just think about pushing a shopping cart. Easy when it's empty, right? A lot harder when it's full of heavy stuff. That's Newton's second law. And this whole massive idea gets packed into probably the most famous equation in all of science. You've definitely seen it before. F equals ma. Force equals mass times acceleration. 3 little letters that explain how basically everything moves. Okay, let's put this one to work. New mission. You're on your bike. We know its mass, m, is about 12 kilograms. And you want to accelerate, a, at 2 meters per second squared. So the question is, how much force do your legs actually need to produce to do that? Well, since F equals m times a, this is super easy. We just multiply them. 12 kilograms times 2 gives us 24 newtons of force. That's it. You just calculated the exact amount of oomph you need to get going. And just like that, level 2, complete. You are on a roll. Just one final level to go. We've cracked stretching, we've cracked moving. Now let's crack the code on something you can't even see. Gas. This is the pressure and squeeze code, also known as Boyle's law. And here's the mastermind for this level, Robert Boyle, another one of these brilliant scientists who figured out the secret rules that invisible things, like gases, have to follow. Every time you open a can of soda and hear that psst sound, you're hearing his work in action. So Boyle's law brings us back to inverse variation. Remember? More of one thing means less of another. For a gas, pressure and volume are opposites. If you crank up the pressure, you squeeze the gas into a smaller space, a smaller volume. It's why you can fit so much air into a scuba tank. It's under crazy high pressure. And the formula for this one is perfect for any kind of before and after scenario. It's just P1V1 equals P2V2. All that means is the pressure times the volume you start with has to equal the pressure times the volume you end with. The numbers change, but the total stays the same. All right, time for the final challenge. Picture a weather balloon. Down on the ground, its volume is 0.6 liters, and the air pressure is 1.2. But as it rises way up into the sky, the air gets thinner and the pressure outside drops to 0.5. So the question is, what happens to the balloon? We just take our formula, plug in the numbers we know, do a tiny bit of algebra, and we find out the new volume is 1.44 liters. It more than doubled in size. This is exactly why a bag of chips puffs up like a pillow on an airplane. It's not magic, it's just Boyle's law. And with that, level 3, complete, you win. And there you have it. The secret code isn't so secret now, is it? We saw how Hooke's law is just direct variation. More pull, more stretch. We saw how Newton's law is a combo deal. More force means more speed, but more weight means less speed. And Boyle's law is pure inverse variation. More pressure, less space. So what's the big takeaway from all this? It means you now have the key to understanding the world's operating system. All these big, scary-sounding laws all come from one super simple, intuitive idea, variation. So the next time you stretch a rubber band, or ride your bike, or see a balloon floating away, you'll know the secret code running behind the scenes. So I'll just leave you with this. Now that you know the code, what are you going to see differently?